We're going to talk about that, and then we're going to show how we could do it in Excel very, very easily. Let's start with the concept of how it works. It's the rate of return of a series of cash flows where the inflows are reinvested at a specific rate. And what that means is that we could have two rates, or we will have two rates. One rate that is the reinvestment rate, so that when we're getting all this money, we can put it in at a lower rate. So let's say our project earns 25% and we get cash flow in year 2. Rather than assume that that can be reinvested at 25%, we're going to specify a rate of return that is what we call the reinvestment rate. So let's say, we're going to stick it in a bank or stick it with our treasury department, and they can earn us 10%. So now you see the value of the modified IRR. It assumes that cash inflows are invested at one rate, namely 10%. And then we look at the overall project returns and say, what rate of return does the project as a whole generate, without the assumption that every single cash flow is at that same rate. The math here is a little bit complicated, but it illustrates the logic. First, we determine all the cash outflows, and that's the money that goes out, and we're going to charge that at a rate of a financing rate. Now, if the cash outflow is at time 0, it's moot because there is no difference in time value, but I just want to park that in your mind, because when we look at the Excel function, it does consider that. Second, we're going to look at all the cash inflows, and then we're going to invest those at the reinvestment rate. And the picture here on the right side here represents that T0 is negative 100, and that's the outflow, so that just comes through as today's dollars. And then T1, 2, and 3 are pushed out into the future at a 10% rate. Now we have a PV of outflows and the inflows. Now we can figure out what is the rate of return in between those. If we outflow this amount for T0 and we have an inflow of this amount in year 3, what is the rate of return between one single payment and one single payment, ignoring that there's anything in between? In this particular case, the answer of the modified IRR is 16.5. Now that's a lot of legwork to do to get this relatively simple number. So we're going to do something a little different. We're going to use Excel. Excel has a function, MIRR, that does all this heavy lifting for us. And there's only 3 parameters in the Excel function. The first is the cash flow series, of course, starting at T0, going out to T, or the end of the time of the cash flow. Then we have to specify what is the financing rate. Financing rate is how much money you pay when you borrow money for the negative cash flows. Then we specify the reinvestment rate. These are the savings rates for the cash inflows that we then take in, push all the way out to the end of the life of the project, and run this MIRR function. So we're going to use the same example of negative 100, then 10, 60, and 8, and look at the MIRR. Equals MIRR, open parens. Again, it prompts us what are the values for the entire period. Then you go comma, what is the financing rate? And in this case, we're going to use 10% for both financing because we only have one negative cash flow. And so that's 16%. If we make it with more digits, it's exactly the same as what we saw previously. We could also do the MIRR for the other project. MIRR, open parens, shade the cash flows, financing rate, comma, reinvestment rate, close parens, you get 17%, and let's again make the 16.89. Both the IRR and the MIRR are superior for the project S.